So hey guys, welcome to another part 2 of review for chemistry 2 exam first quarter. Now in this case, we're gonna be talking about Hess Law. Now again, just a quick recap. The Hess Law means that the total enthalpy change for any chemical reaction is the same regardless of the pathway taken or the number of steps to arrive at that equation. So let's start. So using this data, let's calculate the enthalpy of the combustion of C to carbon monoxide or carbon to CO. Now in this case, our target equation is the highlighted one. It means the color red one. Is we have C solid plus 1/2 O2 gas produces or yields CO gas. Now, in this case, we're not allowed to add a variable and a constant, but the only thing that we're allowed is we can change the sign of the reaction, we can multiply, we can divide. That's it. Only three. We can divide, we can multiply, and we can change its signs. That's it. So anyways, so our target equation, so let's start. This is the first equation, which is CS plus O2 gas yields carbon dioxide. Okay, for this case, the first step is we're gonna let the first equation remain the same, meaning this is gonna be as is. We're not gonna add anything, we're not gonna subtract anything, we're not gonna multiply, divide, or do something to it. It remains as is. So CS plus O2 yields carbon dioxide remains as is. The next step of the reaction, CO gas plus 1/2 O2 gas is CO2. We'll yield CO2 gas. Now, our target equation is CS plus 1/2 O2 gas yields carbon monoxide gas. Now, in this case, that the carbon monoxide is at the reactant side. So what we're gonna do is we're gonna reverse the equation. So step 2 is we reverse the equation. Now, take note, ladies and gentlemen, if we reverse the equation, we're gonna also change the sign. Now, let's take note of the enthalpy for me, the enthalpies of each equation. Since in the equation number 1, it remains as is, so the equation is still negative delta H, H1. Next, in this case is reverse. So from the original equation, we have negative H2. So since we're reversing the second step, from negative, this becomes positive H2. So using these steps, since it is as is, we're just gonna copy it from the equation, from the original equation, and this is since it's reverse, meaning that the carbon dioxide is at the reactant side, and the carbon monoxide gas and 1/2 oxygen gas is at the product side. Okay. Now for this case, the sum of the enthalpy, or the enthalpy for the combustion of C solid plus 1/2 O2 gas that will yield carbon monoxide gas, the formula that we're going to be using is H1, negative H1 plus plus positive H2. Okay. So in this case, carbon dioxide cancels. Since when similar elements are at the opposite side, since the first carbon dioxide is at the reactants at the product side, and in the second equation, the carbon dioxide gas is at the reactant side. I mean, like, this one is on the product side and this one is on the reactant side. They can cancel each other, or they can subtract, or they can decrease, or they can cancel out. So carbon dioxide gas cancels out. In this case, we have O2 and 1/2 O2 gas. Now, all we have to do, this is considered as 1, since we omit writing 1 in chemical equations or chemical reactions because it is understood to be 1 or just 1 atom or 1 mole of it. So in this case, O2 is also at the reactant side and O2 is also at the product side. So we can subtract one mole of oxygen gas minus 1/2 of the oxygen gas on the other side. That gives us 1/2. So our final equation, or for the final answer, is C solid plus 1/2 O2 gas. That will yield carbon monoxide gas. Now take note, the coefficient or the numerical coefficient must be placed where the where the mole coefficient of the reactants or of the equation is much more greater. Meaning, kung makakita ka o if nagsubtract ka o gamay og dako, dito nimo ibutang ang final answer na coefficient sa pinakadako na side. For example, what I mean is, since 1 is greater than 1/2, meaning our final answer is 1/2. So where are we going to place 1/2? On the reactant side, because 1 is greater than 1/2. And 1/2, this is where we get the difference between 1 and 1/2. Since 1/2 is our final answer and 1 is greater than 1/2, we place 1/2 on the reactant side. So this is the final equation that we've reached. Now let's calculate the enthalpy. Now in this case, we have negative 393.5. This is our H1. And we have a positive H2 because from negative it became positive. So we're going to input negative plus positive 283.0. For our final answer, it's negative 110.5. So yes, 110.5 kilojoules. Now in this case, since again, as I've mentioned in my previous video, that the final answer must correspond to its least decimal places in the given. In this case, all of them have the same two of them have the same decimal places. So we're gonna use 4. This is 4. We're gonna have 4 significant figures. 1, 2, 3, 4, 1, 2, 3, 4. So our final answer is negative 110.5 kilojoules.